What's up, guys? Welcome back to Math with McKay. Today, our focus is dividing fractions by whole numbers. There's an acronym that I want you guys to make sure that you remember, okay? And it is KCF, and it stands for keep it, change it, flip it, all right? So what you're going to do is you want to keep the first fraction or number, change the division sign to multiplication, and then you want to flip the second fraction or the second number, okay? So for example, we have 3/8 divided by 1/4. Because a fraction is already a form of division, here you would have 3 division signs in this one equation. But that's impossible to do, so we take that middle division sign, we take it out, we change it to multiplication, and because we're changing the middle division sign to multiplication, we take the reciprocal, we flip the second fraction, okay? So what we're going to focus on first is this example, and we'll see exactly how we'll come out with the same answers, okay? Another thing that I want you guys to make sure that you remember is here on my board, it says multiplying by a fraction is the same as dividing by a whole number, okay? So now we'll take that in consideration when we look at these examples here. So it says, if we were doing this in partners, person A would go ahead and write a division sentence or division problem for those 3 questions. And then person B would write a multiplication problem for the other 3 questions. And if we notice, these are the exact same thing. That's why this statement right here comes into play. Writing or multiplying by a fraction is the same thing as dividing by a whole number. So for example, they say 8 gallons of batter are poured equally into 4 bowls. How many gallons of batter is in each bowl? So when we say equally, that word equally gives us a red flag to say, hey, we're dealing with division. So pretty much, if I were to write this into a division problem, I would say 8 divided by 4. All right? Then we'd have to figure out what the answer is. 8 divided by 4 is 2. So now we're going to do the same thing. We'll look at the part B, okay? So part B says 1/4 of an 8-gallon pail is poured out. How many gallons are poured out? 1 divided by 4, because that's 1/4, times 8. All right? So here we would go ahead and give 8 a denominator of 1, because you can make a whole number into a fraction by giving it a denominator of 1. So then we would go ahead and do the multiplication, and we would say 1 times 8 is 8. Then 4 times 1 is 4. And here we have the same exact problems written in 2 different forms. So here it says 8 divided by 4. This also says 8 divided by 4. 8 divided by 4 is 2. See how we came out with the same exact answer? So multiplying by a fraction is the same as us dividing by a whole number. All right? So now we're going to actually go ahead and get into the multiplication and division of fractions. Okay? So we will go ahead and read this first example. The first example says 3/4 gallon of batter is poured equally into 2 bowls. How many gallons of batter are in each bowl? All right, so here we would go ahead and we would set up a division problem because it says equally. So here I'm going to say 3/4 divided by 2. This is where that K, where keep it, change it, and flip it comes into play. Okay? So when we talk about keep it, okay, we're going to keep this one as it is. So this can be read as 1/2 of 3/4. And we'll see that in a few moments, okay? So let me go ahead and let's zoom in so we can actually see my board. So 3/4 divided by 2. We're going to keep the first fraction. So we'll keep it as 3/4, okay? So 3/4, change it. It says change the division sign to multiplication. And remember, we use that dot now because that letter X is a variable. We don't want to get it mixed up, okay? And then it says flip it. So before we can flip this, I actually have to make this into a fraction. How do you make a whole number into a fraction without changing it? You give it a denominator of 1, all right? So instead of it being 2/1, it is now going to be 1/2. And that goes back into that statement I said when I read it the other way. 1/2 of 3/4. So then we go ahead, after that we follow the rules of multiplication. And remember, the rules of multiplication is numerator times numerator, which will give us 3. And then denominator times denominator, which will give us 8. So 3/4 divided into 2 groups gives us 3/8. All right? Now we'll do another example. Here it says 3/4 divided into, or 3/4 pan of lasagna is shared equally by 6 friends. That word equally and shared equally means that I have to give each person the same amount. So I can't say, hey, you can have 5 and then somebody else can have 2. That's not fair. All right, so we want to make sure that we're fair when we're doing this. So 3/4 divided by 6, okay? How we would do this is we do the same thing. Keep the first fraction, 3/4. Change it, change multiplication to, so I'm going to write it right above, K, C, F. Keep the first fraction, change division to multiplication. I'm going to use the dot so we hold true. And then we flip this. But before we can flip it, I'm going to give it a denominator of 1. So then we can go ahead and actually carry it out, okay? So now instead of this being 6 divided by 1, this is going to be 1/6. And when we flip a fraction, it is called taking the reciprocal. Taking the reciprocal of that fraction, okay? So then we follow the rules of multiplication. Numerator times numerator, 3 times 1. Denominator times denominator is 24. Now this fraction, whenever you're dealing with fractions, you always want to try to get it to its simplest form, unless they say convert it to a decimal or a percent. To get a fraction to its simplest form, you have to find what we call the greatest common factor. The greatest common factor is what is the biggest number that's going to go into both the numerator and the denominator. And how you find the greatest common factor is you start with the numerator and see if the numerator can go into both the numerator and the denominator. If the numerator doesn't work, then you work your way down. So in this case, we check the number 3. Can 3 go into 3? Yes. Can 3 also go into 24? Yes. So 3 in this case would be the greatest common factor. Divide the denominator by 3. All right? So 3 divided by 3 is 1. And then 24 divided by 3 is 8. All right? Guys, now we're going to take the same problem and we're actually going to model this using that rectangle. All right? So how this would work as far as division is, we would take the first fraction and break the rectangle up according to the first fraction. Remember, the denominator tells you how many individual pieces you have, and the numerator tells you how many of those pieces are shaded in. So in this case, I need 3 lines in order to give us 4 individual pieces. All right? And of those 3, of those 4, 3 are shaded in. So now the next thing is, remember we have to, when we're doing the demonstration using the rectangle, we have to go in different directions. So now we need to take this 3/4 and divide it by 6. And how you would do that is, you would just make 6 lines in here. 5 lines in order to get 6 rows. If you remember before, our denominator came out to be 24. There are 24 individual boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And of those 24, there are 3 rows that were shaded in, okay? So that is how we would come out with our answer. And then of course, we kind of simplify it down to where we had 1/8 in the entire thing, okay? So this is how you would actually go ahead and demonstrate it to show. But we need to take it, so we divided it by 6, and then we went ahead and we did the multiplication. So when we do the multiplication, it is, we keep the first one, we change it to multiplication, then we flip the second one. Then we have 3 times 1, which is 3, and then 4 times 6, which is 24. So then we would go ahead and shade in 3 out of the 24 with another color. All right, so then that gives us the answer. But of course, we went ahead and we simplified this. We divided both the numerator and the denominator by 3 in order to get 1/8. Okay, and remember, the colors that overlap gives us our answer.